Alright, so this is a Lamison with inner loop because the absolute value of A is less than absolute value of B. Okay, you make a table. You have to make a table on all these. Your major points: 0, pi over 2, pi, 3 pi over 2, 2 pi. I'm going to plug 0 in. What's sine of 0? 0. 0 times 3 is 0, so 0 plus 1 is 1. Sine of pi over 2 is 1. 1 times 3 is 3, plus 1 is 4. Sine of pi is 0. 0 plus 1 is 1. Sine of 3 pi over 2 is negative 1. Negative 1 times 3 is negative 3. Negative 3 plus 1 is negative 2. Sine of 2 pi is 0. That gives me 1. Now you graph them. Always locate your angle first. 0, go out to ring 1. This and this should be at the same point, same location. Okay.
I'm confused how you did that.
Graph which one?
Like, how you got those points?
How I got those numbers? Like this column right here?
No.
Or how I got graph them?
How you graph?
1, 0. This is 0, ring 1. Pi over 2 is up here. 1, 2, 3, 4. I just graph them those order. 1 pi, there's pi, ring 1. 3 pi over 2 is down here, but since this is negative 2, I'm going to go up 2. Does that make sense? This is supposed to be an inner loop. Where do you think the inner loop is going to occur at these points? Do you see how it went up in here? Watch this. So you're going to graph it in order, and you're going to make it have an inner loop like this. And that's your picture. You start here. That was your first point. Go around, and this is going to be your inner loop, and that's your picture, your graph. Now I'm going to show you how to graph these on your graphing calculator tomorrow. Your graphing calculator does this as well.
Hey, you put a heart inside my calculator?
Oh yeah, this is not the clear heart like you're going to see in a little bit. All right, number 4. This is going to be an inner loop because the absolute value of A is less than absolute value of B. Same points. If I plug 0 in, cosine of 0 is 1. 1 times negative 4 is negative 4, and 1 gives me a negative 3. Cosine of pi over 2 is 0, so that goes away, leaves me that 1. Cosine of pi is negative 1. Negative 1 times negative 4 is positive 4, plus 1 is 5. Cosine of 3 pi over 2 is 0. That goes away. Cosine of 2 pi is 1. 1 times negative 4 is negative 4, plus 1 is negative 3. Those 2 points are the same. Now, always do your angle first. That's 0. But since it's negative 3, you're going in the opposite direction. Where do you think the inner loop is going to occur at? Right here. Do you see how it's inside these 2 points? These set of points. So your inner loop is going to occur there.
Mr. Hector?
Yes, ma'am. Yes, ma'am.
Hey, can we please have Jessica Sherman to check out?
Yes, ma'am.
Never mind. Wrong person.
Okay.
Wrong person.
That loop was kind of weird looking. You just make it just Yes. Now, do you notice something? I want you to look at something. The sine and cosine. Do you see how the sine is still on that vertical line, and you see how the cosine is still on that horizontal? Comment. I had trouble too. Just try your best. You just know there's going to be an inner loop right there. Okay. All right. Are there any questions on those? And the better you practice, the better you get at it. All right. Now let's look at what if A and B are the same absolute value. This type of Lamson has a more specific name. Now this is just a Lamson with an inner loop. This is called a cardioid. Make sure I spelled that correctly. Cardioid. I left an I out. And what does that mean? That means it's going to have a dimple at the pole. Dimple at the pole. So cardioid is a dimple at the pole. So 0, pi over 2, pi, 3 pi over 2, 2 pi. I plug 0 in. The cosine of 0 is 1. 1 times 2 is 2, plus 2 is 4. Plug pi over 2, that gives me 0. 0 plus 2 is 2. Cosine of pi is negative 1. Negative 1 times 2 is negative 2, plus 2 is 0. 3 pi over 2, cosine's at 0, plus 2 is 2. And that gives me 4. So, go to the fourth ring, 1, 2, 3, 4. Now let me tell you what I mean by dimple. I'm going to graph it in the order. You see how I did a dimple right there? That's your graph. There's the heart. That's the dimple. You make a dimple at the pole. If the absolute value of these numbers, A and B, it means there's going to be a dimple. Notice its cosine. Is it still around that horizontal line? Yes. We're going to come back to this one, but let's go and talk about what if A is greater than B. This type of Lamson has a dimple, but it's not at the pole. The only difference between cardioid and this right here, they both have dimples. The cardioid has a dimple at the pole. Okay? Does that make sense? So if A is greater than B, this type of Lamson is a Lamson with a dimple. All right. If I plug 0 in here, sine of 0 is 0. That gives me 3. Sine of pi over 2 is 1. 1 times 2 is 2, plus 3 is 5. Sine of pi is 0. That gives me 3. Sine of 3 pi over 2 is negative 1. That gives me positive 1. And that gives me 3. My angle is 0. Come out to 3. 1, 2, 3. Let's talk about this. This is where students have trouble about where is my dimple going to occur if it's not at the pole. Yes, down here. It will not be at the 2 points that's on the same line, okay? And it will not be the point furthest away from the pole. Do you see how that's furthest away? So your dimple will be here. Okay. So, there's your graph. Notice it is a sine, and you see it's around that vertical axis right there. Okay, let's go back and look at. So you said, Mr. Fisher, when you asked me to tell me what figure this is for Lamsons, we just focus on Lamsons. If it's a lambison with inner loop, you would put lambison with inner loop. If it's a dimple at the pole, you would not put lambison. You put the specific name cardioid, okay? And if it's just a dimple, if the A is greater than B, you will put lambison with dimple. Does that make sense? So let's go back and look at number 6. Okay, so if you saw this, what name do I expect you to call this? You would call this a cardioid because the A and B have the same absolute value, okay? So, because they have the same absolute value, there would be a dimple here. Will it be around the horizontal or the vertical axis? Vertical. So let's graph this. So you got 0, pi over 2, pi, 3 pi over 2, 2 pi. If I plug 0 in here, sine of 0 is 0. That gives me 2. Sine of pi over 2 is 1. 1 times 2 is negative 2. That's going to give me 0. Sine of pi, that would give me 2. 3 pi over 2, that would be negative 1 times negative 2 is 2, plus 2 is 4. Sine of 2 pi is 0, it gives me 2. Take a moment to make sure you understand how I'm getting those values here. Remember, in polar coordinates, r comma theta, so theta goes here. I'm plugging in, that's why I put them here, and my answers are in this column. It's backwards from an x and y table. If I was to graph, you locate your angle. 0 come out to 2. These are easy because you know that the dimple has to be at the pole. Which one?
Shouldn't it be like right side up?
Oh yeah, it should. Sorry. So should be like that, shouldn't it? Sorry. Is everybody good? Thank you for catching that. Yeah, sorry, I made a mistake. Number 8. Okay, the A value, the absolute value of A is greater than B. So this is just a lambison with a what? Dimple. Will it be at the pole? No. Last example. Cosine of 0 is 1. 4 minus 2 is 2. Cosine of pi over 2 is 0, so that gives me 4. Cosine of pi is negative 1. Negative 1 times negative 2 is positive 2. It gives me 6. That gives me 4. And I'm back at 2. So 0, 2. Okay, this one's cut close. Now, guys, I think there's some in your homework where it comes off the graph. Just extend your graph and draw it the best. Now, where will my dimple be? Will it be either of these 2 points that's down the same line? This point's furthest from the pole, isn't it? Will it be there? Your dimple's going to be at that point, okay? Make it at that point. Made my dimple right there. So far we looked at circles and lambisons. Tomorrow are roses. That means you're going to have flower petals.
What?
Flower petals.
It's like you right there.
And I'm going to show you how to graph this on the calculator. So right now you need to make sure that you can tell the ones apart. And then we got ones that look like both sides on first.
I'm so excited. That is cute.
And let me tell you, there might be a part project with it. Oh, never mind. You got that real project. All right. Are there any questions?
No, we can still do the part.
How do you feel on the this learning target today? I need a hand signal. Okay. Hand signal, everyone.
Hey, we can still do that project though.
I can do. We can do something like this, though.
We'll still do it.
Just,
Hey, I'm gonna need a easier points before